These models will not let me go to sleep. Throughout the day, I was exploring OpenAI's GPT-4o and Falcon from yesterday, and then Google has dropped this PaliGemma. In my previous video, I showed you how you can get this PaliGemma installed locally and then process the images. And I can tell you one thing, whatever I have read in the last few hours, that this model is one of the finest small model which can do vision. In this video, I am going to show you how easily you can do fine tuning of this PaliGemma model by using Google Colab. That's true, for free on T4 GPU. Before that, let me give you a very quick overview of this model. If you want more detail, please refer to my previous video which I just showed you on the channel. So this PaliGemma 3 billion is vision language model that was inspired by Pali 3 recipe. It is built on SIGLib visual encoder and the Gemma 2 billion language model. PaliGemma takes as input one or more images which are turned into soft tokens by SIGLib encoder and input text that is tokenized by Gemma's tokenizer. And this figure shows the whole process. The image tokens and prefix tokens are concatenated and passed to the Gemma decoder with full block attention, which then generates an output text autoregressively with masked attention. There are various stages to it, for stage 0, 1, 2, 3, and I intend to make another separate video to go into detail, but I will just give you that hint of the fine-tune state because we are going to fine-tune this PaliGemma in this video. The base models are transferred to specific tasks by fine-tuning, and the Google has also released the checkpoints fine-tuned on most of the benchmarks they have evaluated. And I will be covering them in the coming days one by one because there are so many. You won't believe that Google has released 116 new models just in this family in PaliGemma. So just let it sink. 116 new models just in this family, fine-tuned on various tasks, pre-trained, fine-tuned, mixed. I think the world has gone crazy because there are so many models and all open source are, and all of them are top vision language models. Anyway, let's go to my Google Colab and then we will get cracking on it. Now there is only one prerequisite which you need, which is also free. You don't need to pay anything. You would need a Kaggle API key and Kaggle username. So this is Kaggle's website, so kaggle.com, KAGGLE.com. Just sign up with your Google account there, and then once you are signed up, then go to settings. So when you click on your profile, you can just click on settings here on the top right, and then scroll down. There you will see this API section. Just click on create new token, and it is going to ask you to download this kaggle.json file. Just download it, and in this file you will find two things: your username, Kaggle username, and your Kaggle API key. Grab that, go back to Google Colab. On the left hand side, click on this key icon. Here, just create a new secret. So one secret should be named as Kaggle underscore username. Put your Kaggle username there, and then second key should be Kaggle underscore key, where you should be putting your API key from Kaggle. So once you do that, just click on this tick button, which means that these secrets will be available to this Colab. And that's all you need to do in terms of prerequisite. Now let's another thing, go to runtime, change runtime type to T4 GPU. So hats off to Google for giving this free GPU for us poor mere mortals. Let's install some of the prerequisites, and this Colab, don't worry about these commands, these are present on their GitHub repo. You can check it out. All they are doing here is they are cloning the repo and simply installing all the prerequisites. So let's wait for it to finish. It don't take too long. It is happening in the quiet mode, so should be good. All the prerequisites are done. Let's import those secrets. You see that I am importing that Kaggle username and Kaggle key from the secrets which I just defined. And now let's download the model, which means checkpoint, tokenizer, and the dataset. Let me run it. while I explain what is happening. We are simply importing some of the libraries. We are specifying this PaliGemma model here. And then this is a pre-trained model, by the way, because we need to fine tune it. And then we are downloading model. Then we are downloading tokenizer. And then lastly, we are just downloading this long cap 100 dataset, smallish dataset. So let's wait for it to finish. Once that is done, we will proceed further. And you see that model is being downloaded from Kaggle, and that is why we needed this. By the way, in my previous video, I used Hugging Face. So just in case you want to use Hugging Face, then you won't need you don't need the Hugging Face key because it's not a gated model at Hugging Face. Anyway, so we are using Kaggle, so that is why we have given this. Let's wait for it to finish and then we will proceed further. Model checkpoints are done and now it is downloading model tokenizer, as you can see, and then downloading the data set. So hopefully should be done fairly soon. And data set is also done. Let's print out some of the values which we have downloaded, the version and stuff from the middle, from the models, the visible devices plus jack. So this is what we are using. Jack's version is this, and of course there is one GPU. And now let's specify the configuration for our model. So all we are doing here is we are just freezing the model. We are specifying the vocabulary size, and this is where we are setting the config to the model, and then we are loading the parameters for the PaliGemma, and then we are defining the decode function. So let's wait for it to finish. That is done, and now let's move these parameters to the GPU which we are using. So if you look at this command, this is a simple Python function where it is checking that it's a trainable parameter, which it is. So it is sharding it and moving it to GPUs. And you can see that is done fairly quickly, which is awesome. And now let's pre-process our inputs to the model. So let me run it and I will tell you what exactly is happening here. So if you go above, all we are doing it, we are just defining this pre-process image. So because this is a vision language model, VLM, so the model has been trained to handle images of different size, and that is what we are setting here. We are simply defining this pre-processing the image, if it's in the raw format or whatever, and then whatever tokens have been given to the model, that text of course, and then we are post-processing the tokens after they are done. And now let's iterate over the data set which has been given, and we are simply defining again a couple of functions here because we are going to call these functions later. So one is for the training and one is for the validation, and then we are first iterating over the data set and then we are validating it. Let's also look at some of the training examples. So if I run this code, if you see, so I'm just rendering it inline here, and then if you scroll down, this is what will be, this new model will be trained on. So there are images and text, and that is why if you go above here, we are going through some of the training set, validation set, and text and image, both of it. There you go. So this is all the training examples. And now let's define the training examples and loop. And I know this is a lot of code, but in a sense, just remember that we are simply giving the loss function and the training data set and validation data set to the model, and that's all we are doing. And then we are also defining some of the functions. For example, this is how model is going to make predictions, and this is how model is going to make some of the loss function through the gradient. So eventually, now let's run the training loop. So if I run this and if I show you, this is where we are defining batch size, training example, learning rate, and then we are just stepping through it in the training steps. And if I scroll down, you will see it will start soon, and then it is going to go step by step. So you see model prediction is at step 1. So I will just let it run for a few more minutes because it is going to show. There you go. So it already has started showing us some of the training for every step. So you see it's the beauty of a puff sleeve. So this is a text and there is an image, and then how to wear a maxi dress for summer, and then this is step 2. and then it is also showing you the loss, and you see as the model is progressing, loss is decreasing too. So at the first step the loss was 3, and this is the loss is decreasing. At a very simple high level, what loss means is that initially the model is given the random weights, and then we give it the data, the training data, model reads it, model generates some sort of predictions, and then they are matched with the correct answer. And if the loss is higher, of course, and then there is a back propagation where some function, some algo is applied, or some some optimization algorithm like ADMW or stochastic gradient descent happens, and the loss starts decreasing. And gradually model learns that what is a true answer, and with the every passage of turn, iteration, model learns more and more, and the loss keeps decreasing, as you can see here. So let's wait for all of these steps to finish. Hopefully the GPU will sustain. Fine tuning is still going on, and it has produced some results at step 16, where it has of course built upon the previous answer, and then it is just going through steps by step. So let's wait for it. There you go. So it is at step number 32 at the moment, and you see the loss is decreasing. And fine tuning is at its last legs. You see that it is almost done here, and the loss has come down really low now, which is great. Should be done by any minute, and then you can simply evaluate the model or use it for your own purposes. There you go. So already it has done, and if you go above, these are the model predictions at step 64. So if you go at the very top and then compare it with these answers, there is a huge difference between the responses. For example, I'm not sure if I can go up quickly. I can. So here at the very end, if we go up, sorry for this, but I just wanted to show you. But step 16, look at this answer, and then if you come down, look at this answer. There is C difference between the quality of the response. If you further want to evaluate it, you can simply run this code, sorry, which is going to iterate through the predictions and show you the model predictions on the same data set which you are using. Sometimes it takes a bit of a time, sometimes it is quick, but it should be similar to what model has presented here in this step. And it is just iterating through all the examples now. So all in all, the crux of the matter is that no matter what your text is, image is, if you have any custom data set where you have a text and then image, you can simply fine tune your own model on top of that, and you will use it for your own use case locally on Colab, wherever you like. Sky is the limit. So that's it, guys. I hope that you enjoyed it. Really amazing model. I think the more I delve deeper into it, the more I like it. Let me know what do you think. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network, as it helps a lot. Thanks for watching.